In 1985, Coca-Cola made one of the worst business decisions in history. A series of blind taste tests revealed that people preferred Pepsi's sweeter taste over that of Coke. So Coke spent $4 million developing a sweeter version called New Coke. It was a complete disaster. The stock price plummeted, customers revolted, and they received 1,500 angry phone calls a day. In just 79 days, they brought back Classic Coke, and to this day, cans still say classic or original taste to differentiate from a disaster that occurred 40 years ago. That's like if your mom posted your failed report card on the fridge for like 40 years. But could better data have prevented the New Coke disaster? The core problem is that Coca-Cola was focused on a single set of metrics, and they forgot about everything else. They measured taste with sips, ignoring that results might be different if somebody was given a full can. I mean, a spoonful of frosting is delicious, but do you really want to eat the whole tub? You know what? Don't answer that. Meanwhile, blind taste tests eliminated brand loyalty, which is a critical customer decision-making factor. Most importantly, they failed to recognize that the brand had become ingrained in what people viewed as the American experience. Drinking Coke was about more than just the taste. They used the data they had, but lacked the context to make the right decision. So how could they have done things differently? Today, a company like Coca-Cola would capture data from many sources, such as point of sale data, social media sentiment, customer loyalty programs, and brand attachment metrics. This creates a much more holistic view of the products and the brand. To be fair to Coca-Cola, the world was very different in the 80s. Today, we have social media, loyalty programs, and a variety of other metrics. Back then, data was mostly on paper. Loyalty programs were physical punch cards, the kind that bloat your wallet until you can't sit straight and end up injuring your back. Just me? Yeah, just me. Surveys and focus group data captured brand awareness, but they were still on paper. Correlating all of this was a difficult manual process. This is where companies started their data journey, with paper records and manual processes. These challenges led businesses to digitize their paperwork. But life was simpler back then. With small data volumes, developers could keep most context in their heads. A single online transactional processing or OLTP database could store everything. Operational transactions and analytics lived side by side, often in the same tables. In the 80s and even the 90s, this was fine for most businesses. But as data grew, problems emerged. As technology advanced, the data often grew faster than the business itself. When that happened, databases began to struggle. Analytical workloads run against the operational data often impacted users. Read replicas were introduced to separate the analytics and operational work, but these were a temporary fix. The core issue is that OLTP databases are optimized for reading single records, not the complex analysis businesses needed. Imagine Coca-Cola computing total global sales one row at a time. That would be incredibly expensive. To properly serve analytical workloads, a new kind of database was needed. This is where online analytics processing, or OLAP, enters the picture. Most modern OLAP solutions use column-based storage, unlike traditional row-based systems. Columnar formats are optimized for reading entire columns, not just rows, which is a major advantage for analytics. They're more efficient for aggregations like summing or averaging a column. They also offer better compression, saving space and optimizing resource usage. To solve the analytics problem, new technologies were created. In the late 80s and early 90s, data warehouses designed for structured data and OLAP queries began to appear. Then in the 2000s, as companies accumulated logs, images, and videos, data lakes were created for storing unstructured or semi-structured data. Unfortunately, managing these as separate solutions was cumbersome, and data in lakes was hard to analyze efficiently. In the late 2010s, data lakehouses emerged. The term was popularized in January 2020 with a blog post from Databricks, but the concept existed prior to that. Lakehouses combined the best features of warehouses and lakes, allowing OLAP queries on all of the data, whether it was structured or not. They included support for key features such as ACID transactions and schema enforcement. But all of this introduced a new problem. How do companies like Coca-Cola get data from operational OLTP databases into their analytical OLAP systems? Extract, transform, and load, or ETL, evolved as a way to move data from the operational space into the analytical space. Essentially, you have a process that breaks down into three steps. You start by extracting the data from your operational database. Then, a series of transformations are applied to that data in order to make it better suited for analytical processing. And finally, you load the transformed data into your analytical database. Picture Coca-Cola taking sales data from each of their distributors and aggregating that data into unified tables that present a broad view of the global business. Building ETL pipelines is a big part of a data engineer's job. Unfortunately, it just gets more complicated from there. Sometimes data in an analytical database needs to make its way back to the operational side. At that point, we need to introduce a reverse ETL job. For example, if Coke was collecting social media sentiment data, their analytics might reveal potential customers who would benefit from promotions. This data could be fed back to their operational systems to improve sales and marketing. Going beyond reverse ETL, as data lakes and lakehouses rose in popularity, it wasn't necessary to transform the data ahead of time. Raw files could be dumped directly into the lake or lakehouse and then transformed after. This led to extract, load, and transform, or ELT pipelines. Naturally, that led to hybrid options with transformations happening at various points in the pipeline. And so the modern data engineering landscape has grown fairly complex. Imagine running pipelines at scale with hundreds or even thousands of transformations. It's not easy being a data engineer, is it? Now let's go back to Coca-Cola. Using the knowledge and tools available today, how can businesses like Coca-Cola avoid making disastrous brand decisions in the future? To start, they need to capture more data. In Coke's case, this includes their taste test results, but also sales transactions, social media, loyalty programs, and more. If they had been capturing and correlating all of this data, they might have noticed some interesting trends. For example, they might have seen people on social media posing in pictures with Coke-branded products and recognized this represents a nostalgic connection that goes beyond just a flavor. Or they might have seen sales or loyalty data demonstrating that customers were buying their product week after week, even when presented with other alternatives, because they were loyal to the brand. But in truth, it isn't any one of these things that should be making the decision. It's all of them. Coke's original mistake was looking at the individual metrics in isolation and failing to see the bigger picture. The challenge then is to engineer all of this data into a single unified view that captures how committed people are to the brand. If Coke had this capability back in 1985, they might have recognized that Coca-Cola had become a cultural phenomenon and that messing with the formula could destroy everything they'd built. They could have figured out that there was no need for new Coke, saving themselves $4 million in development costs, along with the negative effects of the actual launch. This then is the job of the data engineer, taking data that is usually viewed in isolation and combining it so that it's available to the right people at the right time. According to Benjamin Rogojan, data engineering isn't about perfect data. It's about building the perfect environment for data to thrive. Think about this for a moment. In 1985, Coke spent 6 months conducting market research with 200,000 taste tests across 13 cities. Today, Netflix processes your viewing behavior and updates your recommendations in 200 milliseconds, while you're still deciding what to watch. That's not just an improvement, that's a fundamental transformation in how businesses operate. I'm sure your business has some concrete service level agreements that dictate how fast you have to be to serve results. What do those look like? I'm betting it's not hours or days. But let me know in the comments. Now, this revolution didn't happen overnight. In the early days of data engineering, batch processing made perfect sense. You'd collect data through the day, process it overnight, and have reports ready the next morning. Data like market research might be collected quarterly from focus groups and other analysis. Business strategy might be reviewed even less frequently. This was in part limited by the technologies available at the time, like Hadoop or Hive. But the world has changed. Modern businesses are looking for real-time sales dashboards, streaming market analysis from sources like social media, instant feedback loops that allow the business to adjust on the fly. And this is driven by modern technologies like Kafka or Flink. We've gone from 6-month research cycles to sub-second decision making. And with the development of AI tools, this is only getting faster. Businesses need to be prepared for instantaneous decisions. When software can process and react faster than human thought, waiting for monthly, daily, or even hourly reports becomes a competitive disadvantage. This is why data engineers must shift from batch first to streaming first thinking, because in a 200 millisecond world, 6-month decisions are business suicide.